Okay, so this will be our last notes on trig. Today we're going to be solving triangles, which means basically find all of the missing pieces. Every triangle has 3 sides and 3 angles, right? So if I look at a triangle like this, they gave us 2 of the sides and 1 of the angles. I just have to find the other 3 pieces. I'm going to need to find this 3rd side, and I'm going to need to find these other 2 angles, and that's it. So basically, we're doing the same thing that we have been. It's just we might need to do a couple different equations for one problem. And I want you to remember that we have more tools in our tool belt aside from just trig. We've already learned some other stuff. We learned the Pythagorean theorem. We practiced that a whole bunch in chapter 2 and chapter 3. And then we also learned our triangle angle sum, the fact that all angles in a triangle add up to 180. Okay, so we'll be using those 2 things as well. So typically on a problem like this, you'll end up using trig once, maybe twice. You'll use the triangle angle sum, and sometimes we'll use the Pythagorean theorem. All right, so let's just launch into it. Which of these 2 triangles that you see right here would be a good one for the Pythagorean theorem? The first one, number 1 or number 2? Remember, to use the Pythagorean theorem, we need 2 sides, and we're looking for the 3rd side. So which one? The first one we could use Pythagorean, right? So let's use it to solve this side. Let's give it a name. Do you guys want to call this? What do you want to call this side here? Call it, you know what? I'm going to say let's call it lowercase b because it's across from uppercase B. It does kind of look like a 6. We'll have to be very careful. And let's set up an equation to solve for b. Keep in mind when we write our equation, the hypotenuse has to be on this side of the equals. So we're going to have our 9 squared here, then our b squared plus 6 squared over here. You guys writing this down? Let's get this in our notes. So let's simplify here. B squared plus 6 squared is 36. Folks, I need you to pause your side conversations, please. Thank you. And 9 squared is 81. What are you going to do next to solve this? Minus 36 both sides. (81 minus 36). My mental math muscles are a little weak today. 45. And for these problems, we're just going to be rounding to a decimal place. I don't know the square root of 45. 6.7. Just punching it in my calculator to verify. Yeah, we'll say about 6.7. So cool, we've got one of our missing sides. Now we have all 3 of the sides. That's good. We just need 2 more angles in this triangle. Let's finish this one up before we start on the second triangle. We can solve for the angle at A or at B. It doesn't really matter. Does anybody have a preference which one we do first? You want to do the A angle? I heard A first. Why don't you try B? Okay, and I'll do A. And then we'll compare our answers. We're going to get different answers, but when we use those to solve for the others, we should get the same. So I'm going to go for A, and I'm going to call it theta is what we've been calling our angles. So I'll put a theta there. And let's label our 3 sides because I think we're going to need to use trig for this. So label your 3 sides. We've got hypotenuse. For me, I'm using the angle at theta here, so this would be opposite and this would be adjacent. This gets a little tricky here because we need to pick our trig function based on SOHCAHTOA, TOA, right? That means I need 2 sides. And really, I could use any 2 sides I want. I've got options here. Do you see how I got different options? What would be the smart choice for my two sides though? What would you choose for your two sides? Which one? You're gonna go, you want to use the 9 and the 6 to do sine? Why are you staying away from the 6.7? That is the smart choice. You don't know how to explain? Anybody want to jump in? It's easier to mess up? Yeah, kind of. Anybody got another idea? It's a decimal, so it takes a little bit longer. Is it exactly 6.7? Didn't we round it off to get 6.7? But these two are exactly 6 and exactly 9, right? So maybe it would be better to use the ones that are exact. Also, what if I made a mistake when I did this 6.7? I'm pretty sure we did it right. But just in case, I know that these two numbers are correct. So I'm going to go with the safe bets, the one that were already on the paper before I started this. I'm going to go with the 6 and the 9. Since that's opposite and hypotenuse, we want to use a sine equation. So going back to our trig skills we've been developing, angle always goes inside the parentheses. Our angle is unknown, it's theta. And sine is opposite over hypotenuse. Opposite was 6, hypotenuse was 9. Any questions about how we got that equation? Deans, remember how to solve an equation like this? How do we get rid of this sine that's on this theta? What do you remember? We put it over 1. We could, and we could cross multiply, but that's going to get us kind of more stuff on this side. We need to do, when the variable's the angle, we need to do something else, not cross multiply. We need to do the inverse. This is one of those problems where we're going to do an inverse sine. And we got to do it on both sides. The inverse and the regular sine will cancel out here. And then we got theta equals whatever the inverse sine of 6 over 9 is. We'll let our calculator do the hard work for that. So second sine, 6 divided by 9 inside of it comes out to about, I'm going to call that 41.8 degrees. We're going to end up getting the same answer. Good. So I got 41.8 for this. Now, do we need to do another trig equation to find our third angle? No, because what other fact do we know that's going to make this easier? So we've got 3 angles here adding up to 180, right? We're already using up 90 here. So don't these 2 angles here have to add up to the other 90? Well, I've got one of them. What would add up with 90 to give you 41.8? 48.2, which is what you got doing it the other way. Awesome. So basically, I'm using the fact that the angles all add up to 360. Sorry, I made a mistake there. 180. Thank you for the correction. So I'm going to go 180 minus the 90 that we had right there, minus the 41.8 that we just got. And that should give me my third angle. Which comes out to about 48.2 degrees. So we have solved the triangle, we found the missing side, and we found both of our missing angles. We ended up using all 3 tools. We used Pythagorean theorem, we used trigonometry, and we used the triangle angle sum. Any questions on our first example? You guys are doing great. Can I ask one more time that the side conversations get paused? It's been a few. Thank you. You guys are going to get a chance to work together here in a minute. Let's just go through one more of these. All right. So this one, let's see what we got. We've got 1 side and 2 angles. So we need to find 2 more sides and 1 more angle. What would be the easy thing to find? The angle would be pretty easy, right? Because we know that the angles all add up to, I just made a mistake on this a second ago. I said 360, but I really meant to say 180. Let's go ahead and find this last angle. Let's go 180 and then subtract off the two angles that we know. There's a 90 and a 51. If we take those two away, we should be left over with 39. So we have found our missing angle. Now we just need two sides. Can we do Pythagorean theorem on this one? We could only use Pythagorean theorem if we're missing one side of a right triangle, not if we're missing two. So we're going to have to use trigonometry. So let's label our sides. I'm going to go ahead and go with the 51-degree angle. Again, I'm pretty certain this 39 is correct, but the 51 was in the original problem. So I think that's the safe angle to use. I'm going to label hypotenuse and opposite and adjacent. Question? Pythagorean theorem with angles, that's kind of the angle sum thing. Yeah, and that's as close as you're going to get. The question was, is there a version of the Pythagorean theorem that deals with angles instead? And none that I know of, not where you're like squaring angles or anything like that. Some point later on this year, we'll actually prove the Pythagorean theorem with cutting out some areas of different squares and triangles and stuff. It's pretty neat. Stay tuned for that. Excuse me. All right, which side do we want to solve for first, the opposite or the hypotenuse? We're going to have to do both. So which one should we do first? Opposite? Okay, let's do the opposite first. It's across from uppercase B, so I'm going to call it lowercase b. And if I'm going to solve for this, then I'm using I've got to use that side, and I have to use one side that I know. So it looks like adjacent and opposite. If I'm writing an equation with adjacent and opposite, is that sine, cosine, or tangent? Tangent has adjacent and opposite in it. So let's write a tangent equation. I'm impressed you guys are getting really good at this trig stuff. Did you think it was going to be like this when we started trig? You think it was going to be a little bit harder? It is difficult. I mean, it's a challenging thing. You guys have just picked it up very quickly. Okay, angle in here. You didn't use calculators. Did you use tables? Yep. Was your math teacher must have been an old school person? I love that argument. You're not always going to have a calculator. Well, I guess if the battery on your phone dies, you don't have a calculator. Chances are you're not going to be carrying trig tables around with you either, though. So back in the day before calculators, we had to look up values for like the sine of or the tangent of 51. We would look them up in the back of our math textbooks in these tables. I'll show you sometime. I've got a really old math book here. I'll bring it in sometime. You can see. Okay, let me just double check I did this right. I put the angle inside the parentheses, and then tangent is opposite on the top, adjacent on the bottom. I did opposite on the top and adjacent on the bottom. Feeling good? All right, so this is the one where we're going to use cross multiply. We don't have our angle inside, so we can't use inverses here. So we'll put this over top of 1, and we'll go ahead and cross multiply this and solve for b. So 1 times b is b. 11 times tangent 51 is, I don't know. We'll let the calculator tell us that. My calculator is coming up with about 13.6. All right, we are almost there, folks. We got an angle. We got one of our sides. We just need to find our other missing side. Any questions before we wrap this one up? All right, I need to find my hypotenuse. I'm going to give it a name. It's across from uppercase C, so I'm going to call it lowercase c. You can call it whatever you want. There's a convention that we use in later math where we always put the side C across from the angle C and the side A across from angle A. Yes. I typed in 11, tan 51, and I got 13.58. You can leave the multiply out. You might be in a different mode than me. Oops. What am I doing here? Oh, 11, 10, 51. 13.6. Are you getting something different? Are you getting something different? Oh, it's just rounding to the nearest whole number. Okay, you've got something going on in your calculator with rounding. We'll figure that out in a second. Call me over in a second and we'll look at that together. Okay, let's solve for C here. That's my hypotenuse. Now, do I want to use the 11 or do I want to use the 13.6? What would be the safer move? Let's go with the 11 because that was in the original problem. So adjacent and hypotenuse would be sine, cosine, or tangent. Adjacent hypotenuse is cosine. Cosine is the one with adjacent and hypotenuse in it. So let's write ourselves a cosine equation. I got room here, I can squeeze it in. All right, we're using the 51 for our angle. And then adjacent over hypotenuse would be 11 over C. We'll go ahead and put this over 1. Again, because our variable's in the fraction, we're going to use cross multiplying. We use inverses when the variable's in the parentheses. We use cross multiplying when the variable's in the fraction. So cross multiplying here, I'm going to have C times cosine 51 equals 1 times 11 is just 11. And this time we're going to have to do one more step to get that C by itself. What is the opposite of multiplying by cosine 51? We'll divide by cosine 51 on both sides. These ones will cancel, leaving us with just C. And over here, we'll let the calculator do the hard work. That's 11 divided by, and this is trying its best to say cosine of 51. I know it doesn't look like it. 11 divided by cosine 51 comes out to about 17.5. And I don't know why I wrote the 5 first. 17.5. Now we've got all of our missing pieces. So this is a tad more complicated than what we've been doing because we're finding multiple pieces of a triangle, where before we were just finding one. So I would like you guys to do a little practice with the problems down below. Give those a try. And when you're finished with that, we've got some options. Let me go ahead and stop the recording here.